went through this lesson fast.
All right, we are ready to go. Okay. So how did everybody do on the homework?
Pretty good.
Yeah.
It seems so bad.
Any questions?
Don't think so.
No.
All right, well, let's carry on then. That was easy. I need one of those easy buttons. All right, let's load up this quiz and get her done. Tell me when you're ready, and I will be happy to start. Although I cannot guarantee a correct answer.
No kidding.
Not if they ask for the margin of error.
Yeah, seriously. You'd think after this far into the class we'd actually know how to do that, but no.
I'm ready whenever you guys are.
Me too.
All right.
I got the first two questions right already.
Okay.
Yay!
Are you actually going to be able to follow along on your phone on this?
Yeah. I have my computer opened with my hotspot, so we're just figuring it out a little bit at a time.
Okay, plugging along. Okay. Suppose we have a set of paired data and let D equal X after minus X before. The null hypothesis is null hypothesis of mean difference equals 0. The alternative hypothesis is mean difference does not equal 0. And the population standard deviation is not known. Jordan collects a sample of size n equals 9 and computes d bar equals 2.2 and the sample standard deviation is 3.3. What is the value of the test statistic? So when I calculated this out, I got 1.818.
So I got 2. Just a
That's
2.
what I got.
I got 2, and then I did it again and got 1.818.
I'm sitting here thinking I'm doing it right because you're getting a decimal, and I'm like, I got 2.
Okay, then I'm going with 2 because that's what I got the first time, and I thought surely it can't be that easy. So
That's what I'm sitting here thinking right now.
okay. Russell, is that what you got?
I'm an idiot, and I was on chapter 13 group quiz, so I had to hurry while you guys were talking, get into it. So I haven't really even tried it yet. I'm like, what is she reading? It doesn't make any sense.
I did that a couple weeks ago, so I understand.
I'm just making up my own quiz as we go. So isn't it great how spontaneous I can be?
I agree with 2.
Okay. Who's going next?
I don't want to go next. I looked at it and I don't know how to do it.
Okay. I'll go next, and I still am not 100% sure I did it right, so. The probability of obtaining a test statistic greater than Jordan's test statistic is 0.0403. Use this probability to determine the p-value for Jordan's hypothesis test. So what I did, since it's a two-tailed test, I assumed that this was the right tail, and then I just doubled it, and I got 0.081, but I don't know if that's how you're supposed to do that.
Yeah, I'm confused on that.
Okay, so my understanding is that in order to get the p-value, you look at when you do the what do you call it? Give me 1 second here. The sample t-test, the one sample t-test, when you analyze your data, and you get the sigma two-tailed bar that comes out, or the little box that comes out, the number that comes. Are you following me so far?
I think so.
Okay. If you're doing a two-tailed test, my understanding is that the number that's in that box is your p-value. And if you are doing a one-tailed test, then you take that number and divide it by 2.
Yeah.
And that number is your p-value.
Yeah.
Which is, oh wait, no, that's the wrong thing. I'm looking. Sorry. I'm clicking on things on my screen. So my number that I got was 0.515.
How'd you get that? Did you?
Well, let me look. Because I wrote it down.
Did you already do this whole quiz?
Yes. Well, most of it. I got up to question 15 because you guys were making me feel bad, like I was taking, like I was doing, like I was, you know,
Holding us back.
I was holding everybody back because
And
here
you
I
were.
got done reading.
That's how I feel, so I totally understand.
So I was trying to be a little more expeditious this week. Yeah, so that being said, I don't know where my numbers are on this one.
I should go find my old stats notes. That's what I should do.
Okay, so hold on. I calculated this out.
Where's your husband when we need him?
Okay, yeah, walk us through how you did it again.
Me?
No.
Oh, okay.
How'd you come up with your answer?
I don't know. I probably did it wrong. Come to
Well,
think of it. Hold on.
so
Three.
you're even getting.
So I'll tell you what I did. I don't no idea if it's right, but here's my thinking on it.
The applet for this one.
So I pulled up the applet, the t-distribution applet,
Okay.
and I put the margin of error, or not the margin of error, we've talked about that too long. I put the degrees of freedom was 8 because it says that our population was 9, so degrees of freedom would be 9 minus 1.
Okay.
Then for the t-score down at the bottom, I put this that it gives us in the equation, the 0.040. And then it's a two-tailed test, so I shaded both to the right and to the left. And then the area under the curve, which is our p-value, according to my notes that I wrote down from a few lessons ago.
You're right.
So the area is 0.961.
Yeah, you're right.
How'd you get 961? Because I did exactly what you just said, and I got 0.9688.
I got that the first time, but what do you have your degrees of freedom as?
8.
Okay, walk me back through after you put in the t-score at the bottom. Then what'd you do?
I shaded the tails to both the right and the left.
Which I have, yeah. And I got 0.9691.
That's what I have too, Russell.
Oh, I thought you said 0.961.
Oh, Well, I maybe did, but I left out a number. Sorry.
Tonight. So
Okay, so you got 0.969.
Yes.
Okay. I'm gonna go with that, considering I can't recall how I actually got this number that I've got.
Well, your number's like maybe a half of that. Yours was 0.5 something, so maybe you just shaded only half.
It's possible.
All right. Well, I can go next. All right. Use the data file, chapter 12, data A1, to answer the next 6 questions. You guys have that pulled up, or do you need to pull that up?
I need to pull it up. Hold on.
Okay.
What's the... Hold on. What's the link for the t-distribution thing again? Does anybody remember?
It
It's
is.
at the top of the quiz.
Oh. I have mine bookmarked, so mine does not have the normal link. It has a weird link.
Yeah. Oh, there it is. Okay. Yeah, I found it. Just kidding. I'm just struggling really bad today. It's fine. Okay. Yep, I'm good now. Sorry.
Okay. All right, so, okay, we've opened that file. Perform a paired samples t-test in SPSS. Be sure that the test does group 1 minus group 2. Use the null hypothesis of mean of the difference equals 0 and an alternative hypothesis of mean of the difference does not equal 0 and a level of significance of 0.1. Okay, what is the test statistic? Okay. So just using SPSS to let it do it for me, I've got 0.407.
that's what I got.
I agree.
You got 0.407?
Uh-huh.
Okay. I'm struggling. I'm sorry.
You're okay. We all have days.
Today is mine. Okay. Did you get negative?
Just positive.
No.
Because I got a or negative. Hold on. Did I do,
Subtracted 2?
huh?
Did you do group 1 minus group 2?
I did group 2 minus group 1.
Do it the other way around.
Because isn't that how it was in the lesson though?
Yeah, but in the instructions it says group 1 minus group 2.
Okay,
Yeah,
that would be my
Sure
problem.
that the test does group 1 minus group 2.
Okay. My bad. Then I got it right. I just did it the wrong way.
All right, on next. What is the p-value? And I got 0.689.
That's what I have.
That's what I got.
Yay.
Sorry, I just have to catch up really fast. I'm so sorry. Your p-value? Okay, yeah, that's what I got too. I'm all caught up now. So sorry.
All right, is it me again?
Yeah.
All right, what is the correct decision based on this evidence? We reject. Right?
I think it's failed to reject
I was saying failed to reject.
because p is
Me
greater than
too.
a.
On p-value
And our little rhyme is when P is low, reject the null, but P was greater in this.
Yeah, sorry. I cannot get those two squared away. Like,
You have to think backwards.
okay, so we failed to reject.
Wait, hold on. Question. So number 6,
Mhm.
it's a two-tailed test. So would you do 0.6? Oh, okay. Never mind. Just forget that I asked that question because I just answered it.
Okay.
That was a dumb question. Okay. I'll do the next one, right? It's my turn.
Yep.
Okay, suppose your alternative hypothesis is instead, alternative hypothesis is that the mean difference is greater than 0. What is the correct decision based on this evidence? So you would still fail to reject the null hypothesis. So the null hypothesis would still be true. We have insufficient evidence that the mean of the difference is greater than 0. That's what I would say.
That's what I say too.
Okay, good.
Yep.
Okay, my turn. All right, we're moving to our other data file. And we're going to do our difference as group 1 minus group 2.
Okay.
Okay, so the question, all right, this data comes from this other data file. The null hypothesis is the mean of the difference equals 0, and the alternative hypothesis is the mean of the difference does not equal 0, and the level of significance is 0.01. Which is greater, n or the degrees of freedom? So n would be greater because degrees of freedom is n minus 1.
Yes.
Agreed.
Yes.
All right. What is the p-value? And I got 0.001.
Me too.
That's what I got.
Yep.
Is it me?
Yes.
All right. What decision do you make? All right, let me go back up and see what ours is. 0.0001. So we are bigger. So we are larger, so we reject.
Yes.
Okay.
Yeah, that's what I have.
Okay.
Okay, you decide to try another alternative hypothesis. This time you use the hypothesis that the mean difference is greater than 0 and you keep the same level of significance. Did the p-value increase or decrease? Decrease.
That's what I have.
That's what I have.
Okay, what decision do you make? Do you fail to reject?
I said reject because the p-value is still smaller than a.
Okay.
That's what I said as well.
All right, sounds good.
All right. Based on your response from the previous question, what conclusion do you make? We have sufficient evidence that there is no mean difference between the two groups. We have insufficient evidence that there is no mean difference between the two groups. We have sufficient evidence that there is a mean difference between the two groups. Email's missing an S. We have insufficient evidence that there is a mean difference between the two groups. I say we have sufficient evidence that there is a mean difference between the two groups.
Yep.
Yes.
But I thought.
All right, as we have seen, the p-value depends on the alternative hypothesis. In general, which alternative hypothesis will give the smallest p-value? Hello?
Those are my kids knocking. I gotta mute it so I can be like, go away.
I would say it would be when the mean difference is less than 0.
That's what I'd say.
I'm not really sure, so I'm just going to go with you guys and agree.
Okay.
Okay, what did you go with? I'm sorry.
The mean difference is less than 0.
Less than 0?
Yeah.
Okay, number 16. Determine the 95% confidence interval for the mean difference between the two groups using group 1 minus group 2. Input your answers below. What is the point estimate for this 95% interval? That's just asking for the mean then, right?
I was just thinking, what the heck's a point estimate?
I think it's just asking for the mean.
The point estimate is when you do the mean plus your whatever decimal your 95% confidence, what is it, like 1.196 or something funny, and then you times that by the,
Are you sure? Because I'm pretty.
I don't know.
I was like, 'cause I'm pretty sure it's just asking for the mean.
It's your best guess.
Yeah, sample mean is point estimate.
Okay, yeah. So
Sample means, okay.
Okay.
I got 11.955
I have to.
Okay.
because I rounded to
I'm sorry,
three
what
decimal
number did you say?
11.955.
You guys, here we are, and it's my question. What is the margin of error?
Oh,
Nobody knows. Nobody knows.
Jason, do you know the formula for margin of error?
Okay, well, let's see. Hold on, because the margin of error formula is still the t standard deviation over the square root of n. I know that's the margin of error formula because I got it from the book. I obviously didn't do the question right, but that is the margin of error formula.
Well, Russell, if we go with the explanation that our instructor is giving you,
Mm-hmm.
if we take the lower and upper 95% confidence intervals, add them together, and divide by 2, it gets 11.955.
Yeah, it's just a little
Which
bit
is
off.
the mean.
I mean, so I think that's
I
about
was like, I used the formula and I got 11.953.
And you use the 1.96 times the standard deviation divided by the square root of n?
I used 3.737
Because
times.
you use the t?
Yeah, I used t. I used t with 15.003 over the square root of 22.
All right, hold on. I'm gonna try that.
So one of them is right hopefully.
Probably neither of them are.
I know. With our luck, that's probably true.
I don't think the teacher's answer is right.
You what?
I don't think she really read my question.
Okay, let's go with yours, Sarah, with that we use the margin of error formula. That is the formula. It is. I wrote it down from the textbook. So,
Okay, so this is the
We'll be watching this
11.953, right?
yeah, 5-3.
So, yeah, so 11.953.
That's what I got.
I got it too, and I did the math.
Just wait till she watches this later and she's like, you dumb kids.
All right, I guess I'm next, right?
Have at it.
All right, input the lower bound. And I'm saying that is 2.898.
Did you get that off of SPS?
Yeah.
That's not what I have off SPS.
I was like, my SPS
5.303.
my SPS is 5.303.
Yeah.
All right, I did something wrong.
Are you looking, do you have both files open at the same time?
Yeah.
Okay.
Are you in the
you're
other file?
There's, one of them is A and one of them is B. Make sure that you're in the B.
I was in the B. I am in the B, but let me do it again. Hold on.
This homework is getting so stressful now. I feel like it used to be so easy. Now it's so stressful.
We're halfway through.
Yeah, I don't know why I got that. You're right. 5.305.
3.
Oh yeah, 3. Yeah, sorry. I forgot that 2 and round up. So 5.303. That's what
Yep.
I got. I don't know where I did the last time.
Who wants to submit it?
Well, we got 19 still to do.
Oh,
Don't submit it yet.
you're right. I just filled it in. I just forgot we hadn't done that one yet.
All right, so input the upper bound and I get 18.607.
Yes.
Yes.
Moment of truth. Here goes. Doo-doo-doo. Oh, we missed 4.
Whoa.
That's the p-value for Jordan's hypothesis test, so that one's wrong.
That's the one that we all struggled on, and I came up with some conclusion about the using the T probability applet, but
Okay, so
Yeah.
what question number is it?
4.
Question 4, we got it wrong.
Yeah. That's the
Okay,
one where they give the test statistic as 0.0403,
Mhm.
and then you use the probability to determine the p-value for Jordan's hypothesis test.
Your explanation sounds so good.
Okay, but I think I might understand that one now. So let me see.
what else did we miss, Marianne?
14.
We missed 14. Please tell me that's not. Oh, okay, good. We missed 14?
We missed 14.
What did you put on 14?
We have insufficient evidence that there is a mean difference between the two groups.
I put sufficient evidence.
I put
Me
sufficient.
too.
Ah, see, I'm marking the wrong thing.
Okay.
Did we get the margin of error right? 17?
Let's look.
Okay. What did you guys put for number 4?
Okay, I have 15 as being wrong too. So I have mean difference is less than 0, and that's wrong too.
Would it be not enough information depends on the problem then? Because
That's
less
what I
than-
think.
less than 0 and greater than 0, I feel like are the same.
That's what I think too. Those are both the same.
Okay, but what did
17
you
is
guys
wrong.
what did you guys put for number 4?
4. Well, hopefully the same thing you did because if you put your answer and you didn't tell
Yep.
us, you're in trouble.
I didn't write it down.
0.96. Okay, are we talking about question 4?
Yeah.
Question 4 is
Okay.
wrong, so don't write the answer down.
So we had put 0.969.
Okay, yeah. That's okay. That's what I got to. So I'll have to
Okay,
figure out.
so question 17 is also wrong.
Ah,
17 is the
17
margin of error, and nobody knows how to do margin of error. We've like talked about this for an hour tonight, I feel
there's
like.
somebody. Well, she said okay. She said take the upper and the lower, or subtract the upper from the lower, right?
She said add them together.
So add the upper and the lower and divide by 2.
Okay, hold on. Okay, do we want to try 11.955?
Well, the other one's not right, so
It's okay, guys. We have 8 attempts if you think about it. We can figure this out.
we have 8 attempts at this.
Well, kind of if you think about it. We have 4 free ones.
Oh.
I guess that's true between all of us, huh?
Okay, which other ones did we miss?
All right,
Wait, let's go back to
so
4.
we missed
Yeah, no one knows 4.
17,
Wait, which one?
17,
Okay,
15.
okay.
I was just a dummy on 14, so you all got that right.
And 4. I don't have any other ideas on how to do 4.
Okay, hold on. Actually, I might have an idea because I think.
Okay, Jason, will you come here?
Okay, the probability of obtaining a test statistic. Okay.
Hey, I fed you. You told me
Okay.
statistics on an empty stomach, and I fed you, so booty over here. Over.
Okay, I think I actually have it figured out.
Here.
I think I. Let me hold on. Because I think I actually have it number 4 figured out.
Is it 1 minus the test statistic?
I think you just double it because it says, okay, the probability of obtaining a test statistic greater than Jordan's test statistic. So that's a p-value right there. So 0.403. And that's greater than. So then it's just the right side.
You just shade half of it, not both of it.
Yeah, that's what I think.
So that gives 0.484,
For your, which one?
number 4, question 4.
I got 0.0806.
Wait, what did you get?
So what I did is I took the probability applet and it says greater than his test statistic. I cannot say that word.
The test statistic goes down in the t-score down at the bottom, though.
Yeah, but it says the probability of obtaining a test statistic greater than Jordan's test statistic is 0.403. So that's a probability number.
Okay, so that's a p number.
Yeah, so then I just doubled it because it's a two-tailed test. So I think I did it right the first time.
But wouldn't it be a one-tailed test because you're trying to get greater than his?
No, so the 0.0403 is the greater than, and you need the less than too.
Oh, okay. Yeah, okay. I got you.
So tell me again your answer, Marianne. Or sorry, Sarah.
I got 0.081 after it's rounded.
Okay.
I don't know if I agree. 0.1 what?
I got 0.81.
Still don't know how you got that.
I just doubled the number and then rounded.
Just double the number?
Yeah, because it's giving you the greater than, so you need the less than too. So I doubled it and then I rounded.
0.081.
Okay.
I don't know if it's right, but that's my understanding of what the question's saying.
Okay.
Do you want me to submit it?
Sure.
All right. We missed one question. We missed. You're gonna love
17?
this. 17.
Because nobody knows. It's impossible to do it.
All right,
So
let
what
me.
did you put as your answer for 17?
17. I put 11.955.
Let's see, the teacher's wrong. Great. Okay.
It's not her explanation.
Let me see if I can find anything about this.
I'm just Googling it. Hold on.
I tried Googling it earlier tonight, and I got the equation from the book.
I feel like either this quiz is wrong or something has to be wrong. Oh, shoot.
What did you put for 15?
Hang on. 15, I put, oh, I didn't submit mine, but we decided on not enough information.
Yeah. Yeah, Googling's not helping me yet. Come on, Google. So what kind of test is that so I can put in the right question in Google?
I put another answer in 17 and it was still wrong too.
Oh, you did?
I did the confidence level of 1.960 times the standard deviation divided by n, and that was not right. So
Yeah, okay. I'm not having any luck Googling it. And in the book, that's what we came up with, right? That formula you just used.
mm-hmm.
And it doesn't like that because that one was pretty close, right? What was your answer? 11.954 something.
0.53 or something using that formula, and her explanation was 0.55.
Yeah, 11.953. Yeah, see, it's like so close.
I was just looking in the questions and conversation discussion boards from this week and last week, but I don't see anyone asking any questions in there about it. So
So we're the only ones that don't know how to do it.
yeah, we're the we cannot be the exception to the class.
I gotta tell you though, it gets really annoying every week to be doing pretty well on stuff, and then all of a sudden it's like this one thing keeps nagging and you can't figure it out.
And I can't think of like any homework, either preparation assignments or homework assignments that ask this, because if there was one, then we could go and, watch the video on how to do the problem. But like I'm getting the answers on the homework stuff, but it's not asking these in the homework.
Yeah.
It's not asking for the margin of error. Can you guys think of any homework questions that have asked that?
Mm-mm.
Me neither.
I'm going slow through the book again.
Should I just start a thread like, how in the heck do you find the margin of error?
So all of the formulas that I were finding look fairly complicated, like through a proportion, and it's doesn't look like anything like what we looked at in the book. So I don't know.
Explain how the margin of error changes with sample size and level of confidence. In this lesson, you should be able to identify a point estimate and margin of error for a confidence interval. Hold on.
Did you guys figure it out?
No, did you make
No.
cookies or anything while you were away?
Okay, so
Does your husband know how to get the margin of error?
Jason? Oh,
I don't know what kind of test it is. I have to look it up too. What kind of test is it?
okay, so
I found a video on it, but what the heck? Does anybody know what the critical value is?
yes, that's the decimal that you use for the, so for a 95% error, that's the, what is it, the 1.645 or whatever value you use for the percentage. Does that make sense? Because for if you use that number for the 95%, it's always the same.
Okay, yeah.
Hey,
So,
I found a video. It's way long, as in like 13 minutes. I think this dude might be a professor at BYUI. Maybe not. He has a shirt and tie on.
I found another thing, and it says to do the t-score times the standard deviation.
I saw that and watched a video on it, but then it explains in that video that, and I tried that when I was messing around with the margin of error from homework 11. And anyways, the video explains that like you can't do that for most problems because I don't know, you don't, because we're working with the standard anyways, we're working with a sample population, not the true population or something like that.
Okay, can I read you these steps that this is saying? This says your critical value is either a t-score or a z-score. So since we're doing,
that's what mine said.
since we're doing the t-score on this one, right? Then we would use that. Okay. So we're going to use the t-score. So find the standard deviation. Let's see. And then you multiply the critical value by the standard deviation. So yeah, it says multiply your t-score by the standard deviation.
Yeah, that's what I just found. And then Ananda was saying that she watched a video about it and they said that you can't use it for every problem.
Seriously.
That's what she was telling me.
Ugh.
But honestly, we could try it anyways, because what do we have to lose at this point?
Yeah.
So I think I found the video that's going to tell us how to fix this, but it's kind of long. So like, anyways, we might like want to watch it and condense it and come back, like send out an email between each other. But anyways, I found this video. This guy is an instructor at BYUI. His name's Mike Richmond. His video on YouTube is called How to Find the Margin of Error Using SPSS. And his description of the video says, this is in response to the many questions on the Lesson 11 homework quiz problem 1, which was the one we were talking about when we started our meeting tonight. But his video is 13 minutes long.
So in 5, you didn't get to the how to do it yet?
Well, no, his voice is really quiet too. The video or the audio is not that great on it, so I'm having a hard time. Like I muted my computer and was trying to listen to it, but it's hard to hear him because I've got background chatter from our conversation too.
Well, I just tried that formula that Mary and I found,
Yeah.
and I got the same answer as the formula that's in the book.
And that was wrong on our quiz, right?
Yeah.
Okay, so that doesn't work.
So I'm wondering if it's either something different and it's like spelled wrong, or if the question is wrong. I don't know, but I feel like if we came up with it that many different ways, I feel like we should at least be close, you know?
The computer doesn't know close, it only knows if it's wrong.
Yeah. Well, but I feel like if we got it the same answer twice, you know, I don't know.
All right. I'm just gonna
I think she needs to go through this and re-clarify this, because if we're all getting it wrong, if everybody in our group is getting it wrong, I gotta say it feels to me like it's not a question of just us not getting it.
Yeah. I don't know.
Because I'm telling you, like looking through the notes and the book and everything that I've printed out about this, there is very little information in here about it.
Yeah, so I don't know. I think I'm going to just ask her what's up with the question, because I honestly don't know what else to do.
Okay. Well, I'm going to watch this 13-minute video and try and digest it, and then if I got anything, I'll email it out to you guys. So.
Thank you.
Okay. Sounds good. Thank you.
Okay, see ya.
Bye-bye.
Good luck. Bye.